since it ends in a 5, that means that 5 is going to divide in there. Does that make sense?
Yeah.
So, so since it ends in a 5, so what I'm going to do is I'm going to grab my calculator really fast. I'm using Desmos, but you could use anything. And I'm going to say, okay, 125 divided
24.
by 5. Yeah, it's 25. So if I try dividing something else like 4 or like 10, it's going to give me a decimal. But if I use 5, it'll give me the whole number.
Oh, okay.
So that means that 125 is 5 and 25.
Okay. And then we will break up the 25.
Yep.
It would be 5.
Yep. 5 and 5.
Okay. But since there's like nothing left over, wouldn't it be? Would there like no longer be a square root?
Well, the two's coming down. These two right here, these are going to come to the outside, but then there is this one left over.
Oh, okay.
So that one's still going to be inside.
So it'd be 10 square root 5.
Mm-hmm.
16. It would be 16 square root 5.
Yeah, good job.
I just think it's more like I'm not good with triple digits.
Yeah, so I would really recommend using your calculator, right? And just like, let's say it's, even if it was like 4 digits, right? Like, let's say it was this massive number, right? It was 2563. Just try divide by 2. Okay, that's a decimal. That didn't work. Let's try divide by 3. That's a decimal. Didn't work. Try by 4. Doesn't work. Try by 5. Doesn't work. Try by 6. Doesn't work. Try by 7. Doesn't work. 8, 9, 10, 11. Oh, look, check it out. 11 times 233. So then in how I split it up, I'd put 11 over here and 233 over here, right?
Oh, okay.
And then I'd go 233 and I'll try dividing by 3, dividing by 2, dividing by 4, dividing by 5, dividing by 6, dividing by 7, dividing by 8. And I would just go until I found another number
Without decimals?
that's not a decimal, yeah.
Oh, okay.
Right. And then if you really, if you're like really stuck, you've been doing it for a long time. So 233, you can go to Google and you can type in, thanks. You can just type in factors of 233 and search for it. And then it will tell you, oh, like this one, it's telling you 233 is a prime number. That means there's nothing else that can come out of it. Right? So let's say you typed in that original, what was it? It was like 2563 or something.
Yeah.
2563, something like that. What are the factors of 2563? It will tell you like 11 and 233, right? So
Yeah.
then it'll tell you that. And so then you know, like, okay, well, that's the only thing that can go into it, 11 and 233. It's probably
Okay.
it's probably not going to be that big of a number. So let's say it was like 244, something like that. Right? It'll tell you, okay, 200, the factors of 244 are 1, 2, 4, 61, 122, and 244. So 1 and 244, they go together. 2 and 122, they go together. 4 times 61, those two go together to give you the 244.
Okay.
See how they broke down the factor pairs here? 1 times that, 2 times that, 4 times this. All of those. So you could use any of those. You don't want to use the 1 option because it's not like,
it's not gonna work in general.
it's just not going to help us, right? Where like if we have 1 and 20, we could use 2 and 122, and then we could break down 122.
I feel like it'd be easier just to use 4.
Yeah, I think it's going to be easier, right? So you can use 4, and then maybe I don't know what 61 is. So I might go up here and be like, okay, what are the factors of 61? The factors of 61. And then it says 61 is prime. right? So when it says prime fact, when the only thing that you can do is 1 and 61, you're like, oh, well, I must be done.
Yeah.
So if it's a prime number, you can't keep going. Does that make sense?
Oh, okay. Yeah.
Yeah. But there probably won't be a lot of that because what we're practicing right now is like putting them together. So most of them won't be prime. But like 5 is a prime number and 2 is a prime number, 3 is a prime number. It's any number that you
Mhm.
can't break down anymore.
Oh, okay. Yeah.
And also Diana. So like when I have like 3 digits number with questions like these, I usually try this thing called prime factorization because like obviously I won't have like 5 times 25 right in my head when I do 125. So with
Mhm.
prime factorization, you use like the smallest number. So like usually you can start with a 2, 3, or in this case you have a 5. So
Yeah.
you will get 5 and 25, right? And then 25, you further divide it to 5 and 5. So like in this way, like you don't have to think of 2 numbers that you can multiply together. So it gives you like some buffer space that I
Mhm.
think it's helpful. Yeah, with any 3 digits number. Yeah.
Oh, okay.
So if you have this number, Diana, you take the 125 and you're like, okay, I can take out 5 from there. So then you would
Mhm.
then on your calculator, you'd say, okay, I have 25 is what happens, right? And then I can say,
Yeah.
okay, I'm gonna divide that by 5 again, and that's going to leave me with 5. And that's how I end up with my 3 5s, the same as these 3 5s over here.
Mhm.
So you can do that with,
Yeah.
yeah, pretty cool. Okay, is there another one of the big number you want to try it on?
11.
Well, 11's the same big number. You want to try
Yeah.
96? You want to try 13?
Yeah.
Okay, let's try 13. Mm, all right. All right. What number could we divide 96 by?
Mhm.
Just start with the smallest number you can think of.
8 and 12.
We could do 8 and 12. Let's see. Yeah, 8 and 12 works. Let's try 8 and 12. And then we could do 4 and 2 and 2 and 2, right?
Mhm.
And 2 and 6 and then 2 and 3, like that.
Mhm.
So this is that way. Or let me show you this, not show you the prime factorization way in case you like it with big numbers. So 96, if I just divide by 2, I get, okay, 96 divided by 2 is 48, right?
Mhm.
And then I'm going to divide that by 2. 48 divided by 2, I get 2 and 24. I say, okay, I'm going to divide that by 2, I get 12. Divide that by 2, I get 6. Divide that by 2, I get 3. And now that I have a prime number here, I have all of the numbers. And all of these numbers are going to be the same as these numbers that you got here.
Ah.
So you have 1, 2, 3, 4, 5 2s, 1, 2, 3, 4, 5 2s, and a 3 and a 3. Do you see how it like they're like 2 methods to get you to the same idea?
Yeah.
Yeah, cool. Okay, now that we've broken it down, we have the 4s coming down, right? The -4. What else? What other groups are we making?
The 2s.
The 2s, one set of 2s here. What else?
Another 2.
Another 2. Then what?
But the other like lonely 2, I guess.
Well, we have a lonely 2 and we have a lonely 3, right?
Yeah.
So neither of them can come to the outside. So what do they have to do inside?
Multiply.
We multiply them back together. So 2 times 3
Yeah.
would be 6 on the inside.
Okay. And then it'll be like -16 in the outside.
Say that again.
It'll be -16 on the outside.
Negative 16, square root 6.
And then we bring down the 24.
We can bring down the 24, but we also need to break it up, remember?
Yeah,
What can we break it into?
6 and 4.
Mhm.
3 and 2 and 2 and 2.
Perfect. Any groups?
Just the 2.
Just the 2 coming to the outside.
And it'd be 6 square root of 6.
Yes, good job. So now we have 2 square root 6 minus 16 square root 6. Do they have the same insides?
Yeah,
Yeah, so what can we do?
subtract.
Yeah,
So it'd be 14 to the square root of 6.
what kind of 14?
Negative.
Yes. Nice, good job, Diana.
Thank you.
Okay, Diana, I have to go get ready for a really, really long meeting. So I am gonna head out, but Miss Yama can help you on 14 if you want, or you could try 14 and then check your work with Miss Yama.
I can do it with her.
Okay, sounds good. Miss
Good
Yama,
luck, Miss Mac.
thank you, thanks.
Mm,
Feel free to email me, Miss Yama, if you need anything. As we're going, I'll try to keep my eye on my email during the meeting.
Sounds good.
Okay, we'll see you later.
See ya.
Bye, Diana.
Bye.